Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for one more very important session in coordination compounds. In this session, we shall see how to arrive at the Iupac names of coordination compounds and ions. Okay, so you can expect more number of questions in your board and other competitive exams from this. So watch and listen till the end to get a clear knowledge without any confusion. So before moving into the nomenclature of coordination compounds, first you should be thorough with certain rules and let us see one by one, right? See the first step, this is the first step to be followed. The first you should fix the cationic and anionic part of the coordination compound. See this is the coordination compound and this coordination compound, the first step should be fixing which is the cationic part and which is the anionic part. Okay, see here, so let me divide this. See, always in a coordination compound, the first part will be the cationic part and the next part will be the anionic part. Okay, so this will be the cationic part and this will be the anionic part. So I'm going to write now how to write. See, K4 potassium, you know? So 4K plus. So it's a cationic part as I told you. So the next one will be the anionic part. Okay, so the anionic part I'm going to write in a square bracket. So FeCN 6 times. Okay, so what could be the charge on this coordination entity? See, this is called as coordination entity or complex ion. Okay, so the charge, since here we are having 4 plus, here it will be 4 minus. Understood, students? So this is how we should fix the cationic and the anionic part. So the first part will be the cationic part and the next part will be the anionic part. Okay, see here. Since see the second step, see if the cation is simple, then it should be named as such. Okay, see if the cation is simple, then it should be named as such. What will be named as such? The name of the particular metal or the cation should be named, right? Since it is not in a complex form, since it is a simple form, you can write the name as such. Okay, see here the same compound I have written K4FeCN6. Okay, so this is a simple compound obviously. So I am dividing here. So here we are having K, is it not? So how will you write? Potassium. The first word should be potassium. Okay, so this is how you should write. So this is the simple way of writing the cation. So it should be written as such. Okay, so this is step 2. So step 1 you might have understood and step 2 also might have understood. Let us see step 3 now. See, next one is step 3. Actually, the procedure of naming the central metal ion depends upon the nature of the complex. Okay. See, we are having two types of complexes. One is cationic complex and the next one is anionic complex. So, depending upon the type of the complex, the name of the complex will be differing. Okay. So, let me explain step 3 here. See, if the complex is in cationic complex form. See here I have given an example. This is the complex ion and see this complex ion is a cationic form. See 3 plus here we are having at the top of the square bracket is okay. So it is a cationic complex. So if this is the case, then the first number and the name of the ligand should be written first, followed by the name of the central metal atom or the ion. Understood? See, if this is the type of complex, cationic complex, here we are having the central metal atom. Fe is the central metal atom and H2O, this is the ligand. Okay, 6 times we are having. So ligands, 6 ligands are we are having same type. So H2O is the ligand and Fe is the central metal atom. So if this is the cationic complex, since we are having a positive charge at the top of the center. Okay, this coordination entity or the complex ion. So if this is the case, if this is the cationic complex, then we should give preference to the ligand first. So number and the name of the ligand should be written first and then comes the central metal atom or the ion, and which is further followed by the oxidation state of the central metal atom in Roman numbers in parentheses. See here, after writing the name of the ligand, number and the name of the ligand, then you should write the name of the central metal ion. Okay, and next comes the oxidation state of this central metal ion and that should be written in Roman numbers and that also should be written in brackets. Okay, parentheses. So let me write and show you now. See how to write this. First let us find out, say what's the ligand here, H2O, is it not? So ligand H2O, it's a neutral ligand, so we'll be writing as aqua. So the name of is aqua. Okay, we should not write as water, it is aqua. So how many number we are having? Here we are having 6. 6 means hexa. Okay, so hexa aqua. So we have written the number and the name of the ligand now. Number is hexa aqua. Hexa aqua. Next comes the central metal. Okay, central metal Fe. Since it is a cationic complex, we can write the name of the metal or the ion as such. Okay, so here iron, IRON. Next comes the oxidation state of this ion. That should be written in bracket. How to find out the oxidation state? Say it is simple. So we need to know the oxidation state of ion, so that we can take as X. So X plus, how many ligands are there? 6. What is the charge of H2O? See, it is a neutral ligand. It's not H2O. So neutral ligand means the charge will be 0. Okay, 6. It's equal to, what is the charge on the net charge on this coordination entity of the complex ion? It's plus 3. Okay, so plus 3. Here Ex plus 0. Is it not? 6 into 0 is equal to 0. Plus 3. So X is equal to plus 3. Understood? X is equal to plus 3. That means Fe, the oxidation state of Fe is plus 3. So how will you write? Here already I have told oxidation state should be written in Roman numbers. It's 1, 2, 3. So this is the name of the compound. Okay. So this is the third rule. Okay. Now let us see the fourth rule. See, if the complex is in anionic complex form, that means a negative complex, first the number and the name of the ligand should be given, followed by the name of the central metal atom or ion ending with ATE, which is further followed by oxidation state in Roman numbers in parentheses. The same pattern you should follow here also for the anionic complex. But the only difference is, see here we have written the name of the central metal atom or the ion as such. It's not iron. But here we should not write like that, because instead of writing the name as such, the last letter should be removed and we should add the letters ATE. 8 should be used. Here I have given an example. AU. AU means aurum, that is gold, is it not? Instead of aurum, you should write as aurate. Understood? So aurate, aurum or aurate. If it is silver, Ag, then it is argentum, then it should be written as argentate. If it is platinum, it should be written as platinate. Okay. Then cobalt, then cobaltate. Chromium means chromate. Understood? Like that. The name of the central metal atom should be changed as 8. Okay. So now how we are going to name this compound? Okay. How you are going to name this complex? So this is an anionic complex, is it not? How will you name this? See, this is what's the ligand present here? It's chloride. Okay, it's not chloride. So how will you write? Since the ligand is present inside the complex, we should write as chlorido. Those things I will explain while explaining the ligands. Okay, how to name the ligands. So here I am simply writing how to write. Okay, chlorido. Okay, tetrachlorido. So what ligand number should be written first? So tetra. How many chloride ions are there? 4. Is it not? So 4 means tetra. Then chlorido. Okay, tetrachlorido. Chlorido. Why we are writing chlorido? That I will explain later. Okay, tetrachlorido. Then how to write this? Aurate. Is it not? AURAT. Instead of writing as aurum, you should use the letters ATE. Aurate. Tetrachlorido aurate. And then you should give the oxidation number, okay, in Roman numbers, okay. How to find out the oxidation number? So we do not know the oxidation number of AU, is it not? AU plus 4 into, see, ligand is 4, is it not? What is the charge of Cl? It is -1, okay. What is the charge on the complex ion or the coordination entity? It is -1, okay. So how will you write? X minus 4 is equal to -1. So X is equal to, how will you write? X is equal to plus 3. Is it not? X is equal to plus 3. So here the oxidation number of this AU is plus 3. So how will you write? 1, 2, 3. So this is how you should write. Okay. So now step 5 is nomenclature of ligands. See, only if you know how to write the name of the ligands, it is possible to write the Iupac naming of this coordination compounds. Okay, because these ligands plays a vital role in the coordination compounds, right? So there are different types of ligands. So different types of ligands are named differently. Okay, so let us see the first type, that is the neutral ligands. See, these neutral ligands will not be having any charge over them. So they are named as molecules, okay, except some few, okay. So I have given some examples here. CO means carbonyl, okay. The name of this is carbonyl. CES means thiocarbonyl, understood. So NO means nitrosyl, okay. These are the names of these molecules, right? Then C5H5En is pyridine. Okay, so NH2, CH2, CH2, NH2 is ethylene diamine. So it can be written as En in parenthesis. Understood? So the names of the molecules can be written as such for the neutral ligands. But for certain compounds like water, CH2O, this is a neutral ligand. Okay, we cannot write as water, but it should be written as aqua. Okay, so some compounds will be having different names. Then the next one is NH3. See, normally we used to call this compound as ammonia, is it not? But that's not the name, right? So here in coordination compound, we should name this ligand as amine. Okay, so amine. So few exceptions are there in the neutral ligands for which we will not be using the name of those molecules, but instead we'll be having a specific name. Understood? So the next one is the positive ligand. If suppose the ligands are positive, then their names will be added with the suffix ium to the particular names. Okay. So normally these type of positive ligands we cannot see them, right? Positive, they rarely occur in the complexes. Okay, positive ligands. So these are some of the examples, and the names of these compounds are nitro. See, nitrosodium. Nitrosodium. Say, as I told you, IUM will be there coming at the end. Okay. So next one is NH2, NH3 plus. So it is HYDRA, hydrazine, is it not? NH2, NH2, NANZINIUM. Okay. See, here also we are having IUM. Next one is NO2 plus. It is nitronium. Okay, nitronium. Understood. So these are the different types. So some few examples I have given for positive ligands. Normally, these positive ligands rarely occur in the complexes. Understood. Next, we shall see the negative ligands, right? See here, the negative ligands, they are named by removing E at the end. See, and adding O to the respective name of the group. So by replacing E with O, we will be naming the negative ligands. Okay. See, I have given some examples for the negative ligands. See, your students, you should be thorough with these ligands. Okay, names of these ligands. Only then it's possible to write the name of the coordination compounds correctly. Okay. So Cl minus means chloride. The normal name is chloride. Okay. So we'll be replacing, we'll be taking out this E, and instead of E, we'll be adding O. So it becomes chloride becomes chlorido. Chloride becomes chlorido. Bromide, bromido. Iodide, iodido. Cyanide, cyanido. Sulfate, SO4 2 minus is sulfate. So E will be replaced by O, sulfato. This is sulfide, sulfido. Acid, acido. Carbonate, carbonato. Thiosulfate, thiosulfato. Sulfite, SO3 2 minus sulfite, sulfito. Oxalate, C2O4 2 minus oxalate, oxalato. Then nitrate, nitrato. Okay, this ONO minus nitrite, nitrito. Then NH2 minus amide. Normal name is amide, but instead of amide, we will be writing as amido in the Iupac naming of coordinate compounds. If NH2 is there, understood. Then here N minus thiocyanate, thiocyanato. Understood. This is how you should write the name of the negative ligands while naming the Iupac nomenclature of this coordination compounds. Understood, students? See here, the next type of ligand is the ambidentate ligand. See here, some monodentate ligands. What do you mean monodentate ligands? There will be only one site for the for bonding. There will be only one bonding site. Okay. So some monodentate ligands contain more than one donor atom and can attach themselves to the central atom through any of its donor atom. Understood? See here, see monodentate ligand Cl minus. This is a monodentate ligand. See, this Cl can be getting attached to the central atom only through Cl. Okay. But there are certain compounds like see the SCN minus. So this is a ambidentate ligand, but it is a monodentate ligand, right? But this SCN minus can get attached to the central atom either by S or by Cn. Understood? So that the atom which is donating the lone pair of electron is called as the donor atom of a ligand. Understood? So here we are having two donor atoms, S and Cn. Okay, we are having S and Cn, but this comes under monodentate. See here, if suppose if the S is the donor, okay, donor atom, then the name will be written like this. So I will write thiocyanato hyphen yes. Okay, understood. If suppose if this Cn is, see here this N, okay, N is the donor, then the name can be written as thiocyanato hyphen cat. Understood. This is how we will be writing depending upon the linkage which is the donor atom, the name of the ligand will be changing. Understood. Okay. So next one is polydentate ligand. See polydentate ligand. See here, if suppose when two or more ligands of same type occur in the same complex, okay, two or more ligands of same type occur in the same complex, then the prefixes di, tri, tetra, penta and hexa are used to indicate the number of each ligand. Understood? For example, so let me give an example here. Already we have seen this one, K4FeCN6. See here, this cyanide, it's the same type, is it not? But it is occurring 6 times. So in that case, he will be writing as hexacyanido. Understood? Hexa. We are making use of this prefix. Okay, hexacyanido. Understood, students? This is okay. If suppose if in a case of polydentate ligand, what will be polydentate ligand? More than two or just one or more donor atoms will be there. Okay. If in a polydentate ligand, if the ligand name itself includes such type of prefixes like di or tri or tetra or penta. For example, ethylene diamine. See, this is a polydentate ligand. See, in this ligand itself, there is the letter di is there. So, not see here. So, this is a polydentate ligand. So, the ligand name itself is having the prefix like di. Okay. In this case, then the ligand name should be placed in parenthesis. Okay. The ligand name should be written in parenthesis and it should be prefixed with bis, tris, tetrakis, pentakis or hexakis. What will be bis? If suppose two ethylene diamines are there, then we can write as bis ethane 1,2-diamine. Bis ethane 1,2-diamine. For example, if suppose 3 ethylene diamines are there, then you should write as tris ethylene diamine. If 4 are there, then tetrakis ethylene diamine. Pentakis, hexakis, like this you should write. Understood? The final rule is order of naming the ligands. Okay. See, when more than one type of ligands are present in a complex, they are named in the alphabetical order regardless of the nature of the charge present on them. See here, if a complex is having more than one type of ligand, then that can be written in alphabetical order. Understood? See here, what are the ligands present here? Chloride, cyanide, nitro, is it not? And then amine. Is it not? So you should, based on the alphabetical order, you should write which comes first. Amine will be coming first. So this will be coming first. Okay, amine, and then comes this chlorido. Is it not? Second, and then cyanide. Okay, third, and then nitrito. Okay, fourth. So how will you write the name of the compound? Try. How many amines are there? 3. Is it not? So try amine. AMM. Okay. So INE, amine. Then chlorido. You should not write as chloride because the chloride ion is present inside the complex. If it is present outside means you can write as chloride. But since it is present inside, it is chlorido. Okay. Then cyanido. Cyanido. Then nitrito. Understood? This is how. So in this order you should write the name of the ligands. Understood? Okay, students. Now we shall see how to write the names of these compounds. Okay, based on the rules we have seen. So we are going to see how to write the names. If you are while writing this, you can get a clear-cut idea. Okay. So let us see the first one. KAgCN twice. Okay. What's the first rule? First we should fix the cationic part and the anionic part. Is it not? So I am going to break this. So this becomes, how will you write? Now what's the cationic part here? K plus, okay, and then anionic part is AgCN twice, is it not? So here, since it's here, we are having one positive charge in the complex, you can write as minus, okay. So we have written. So now we can write the name of the compound. We can start to write the name of the compound. Okay. So what, see here, the positive ion, that is the cation, is a simple cation. Is it not? It's not given inside the complex. It is outside. So it's a simple one. So you can write the name of the particular element as such. Okay. K, that is potassium. So potassium, since it is a simple cation, we are writing the name as such. Okay. Next one is the next complex. Okay, see, this complex is is a negative complex or an anionic complex. In anionic complex, what's the rule we have seen? In anionic complex, the number and the name of the ligand should be written first, and then comes the central metal atom, and the central metal atom also should be added up with the letters AT at the end, and finally we should give the oxidation number of the this as metal atom, central metal atom. Potassium cyanido. Then comes the central metal atom. Okay, central, it is argentum. Is it not? So argentum. But since it is an anionic complex, we cannot write as argentum. Instead, we should write as argentate. Okay, so argentate. Now finally you should finish it with the oxidation number of this silver. Okay. So let us find out the oxidation number of silver now. How will you find out? AgCN twice minus. Is it not? So here we do not know X. So we can write as X. What is the charge on this cyanide? It is -1. Is it not? So 2 into -1. That is equal to, what's the net charge on this coordination entity? It is -1. Is it not? Net charge on the entity is -1. So -1. How will you write now? Find it out. X is equal to -1. Then here +2. That's equal to X is equal to +1. Okay. So what's the oxidation number of silver here? +1. So it should be written in Roman letters. Okay. So this is the name of the compound. Understood? Now check the next compound. CuNH3 4 times SO4. Is it not? So now what we are going to do? First we shall divide it. Okay. First we shall fix the cationic and the anionic part. Okay. So this is always in the complex. The first part will be the cationic part and the next part will be the anionic part. Okay. So let me write here CuNH3 4 times. So this will be the cationic part and the next will be the anionic part. So 4, 2 minus. Is it not? Sulfate, the charge is 2 minus. If so, then this will be 2 plus. Understood, students? And how will you write the name of the compound? First, we should write the name of this complex. Is it not? So this is a cationic complex. If it is a cationic complex, first we should give the number and the name of the ligand. What's the number? It is 4. That means tetra. What's the ligand name? NH3. It is amine. So tetraamine. Okay. Tetraamine. So let me write here. It is tetraamine. AMMINE. Tetraamine. What's the name of the central metal atom? Cu. Since it is a cationic complex, you can directly write the name of the central metal as such. So it's a copper. So you can write as copper. Then you should write the oxidation state, and then finally the name of this ion. Okay, it is sulfate. Since the SO4 2 minus is outside the complex, we can write as sulfate. If it is inside the complex, we should write as sulfato. Since it is outside, we should write as sulfate. Okay, sulfate. Now you find out the oxidation number of this copper. Only then you can write here. How to find out? Let us fix this as X. Okay, X plus, how many ligands are there? 4 into, what is the charge of this amine? It's 0. Since it is a neutral one, it is 0. That's equal to 2 plus 2. Okay. Now X plus becomes 0 is equal to +2. So X is equal to X is equal to plus 2. Understood? So the oxidation number of copper is plus 2. So how will you write 2 here? Okay. So 2 Roman letter. Understood, students? This is how we should write the Iupac. Next, see the next compound Fe H2O 6 times Cl3. Okay. So we shall fix the compound now, cation and anion. So this is cation. The first part will be cation and the next part will be the anion. Okay. So let me write the name here. Fe H2O 6 times. Okay. And the next one is Cl 3 Cl minus. Okay. See the charge on chloride is 3 Cl. So here we can have 3 plus. Understood. So what's the name of the compound? So it is the first part is the cationic complex. Is it not cationic complex? So in that case also we should write the number and the name of the ligand first. Okay. So hexa. It is hexa aqua. Is it not hexa aqua? See here. This is a cationic complex. So you can write the name of the central metal atom as such. Okay. So it is iron. Okay. It is iron, right? And then we should give the oxidation state. And what's the name of this ion? It is chloride. Since it is present outside this square bracket, we can write as chloride. Okay, chloride. CHLORIDE, chloride. Now find out the oxidation state. X plus 6 into it is a what's this? It's a neutral ligand. So 0 is equal to plus 3. Understood? So X is equal to plus 3. Okay. So oxidation number of this ion is plus 3. Okay. So this is the name of the compound. Understood? Okay. See the next compound, students. See, I'm going to divide this like this. Okay. So this becomes the first part becomes K plus. What's the next one? It's PT Cl3 NH3. Okay, so here it's minus. Understood? Okay, since here plus 1, here it's minus 1. Understood? Now write the name of the compound. See here, this is a simple cation. It's not linked with any of the complex. It's not a complex. So we can write the name as potassium. Okay, potassium. And then name of this complex. See, this is an anionic complex. So that in anionic complex, you should write the ligands, number of the ligands first. But here we are having two types of ligands. So since two types of ligands are there, we should follow the alphabetical order. Okay. So which will come first? This is amine and this is chloride, chlorido. Since the Cl is present inside the square bracket, we should not write as chloride, we should write as chlorido. Okay. So amine will come first, then next comes chlorido. Okay. So potassium, amine, potassium, amine. Okay, then trichlorido, trichlorido, trichlorido. Then what's, since it is a anionic complex, the central metal atom should be written as, it should not be written as platinum, instead it should be written as platinate. Okay, so it is platinate, platinate, platinate. Okay, so now its oxidation number should be given. Okay, how to find out the oxidation number? How to find out X? See, this is X plus 3 into, what's the charge of Cl? It's minus 1. Okay, next it's amine, it's a 0. Is it not? It's a 0. Alright, that's equal to minus 1. So X minus 3 is equal to minus 1. So X is equal to what's plus 2. Okay, so here we'll be writing as 2. Understood? So this is how we should write the name of the compound. Okay, then comes the last one. Okay, here also I'm going to divide. So this becomes 2 Na plus. Okay, and next comes nickel. EDTA. What is EDTA? It is ethylene diamine tetraacetic acid. Okay, ethylene. So here becomes 2 minus. Okay. Now we are going to write the name of this compound. How will you write? Since it is a simple or what to say, simple cation, we shall write the name of the compound as such. So sodium, sodium, and then Next comes the complex, is it not? Next one is the complex. See, in this complex, it's a negative ion, is it not? Okay, so it's an anionic complex. So the name of the ligand should be written first. Okay, so ethylene diamine tetraacetate. Tetraacetate. Okay, tetraacetate. Ethylene diamine tetraacetate. Okay, instead of acetate, we will be writing as tetraacetate. And then comes the central metal atom, nickelate. Okay, nickelate. Then should write the oxidation number. How will you find out the oxidation number? See here, this is X for nickel. We can take like this, NiEDTA. Okay, right? So X for EDTA, it is -4. Okay, EDTA -4. What is the charge on this? It is -2. Okay, 2 minus. So X is equal to +2. Okay, so here we will be writing as +2. Understood? So this is the way you should write the name of the coordination compounds. Okay. See here, I have given the names of the compounds, Iupac names, and you are going to arrive at the structure of this for these names. Okay, only then you can get a clear-cut idea. So how to write? Okay, let us see one by one now. So potassium tris oxalatochromate 3. Okay, potassium. It's directly given potassium. That means it's a simple cation. So how to write? First, let us write K. Okay, so simple cation K. Then we can start the complex. Okay, tris oxalatochromate, chromate. Okay, that means a Cr. Since it is given as ATE, it is an anionic complex. Okay, so chromium. Then tris means 3 times oxalato. Okay, then oxalato. What is oxalato? Oxalate, C2O4. Okay, tris means 3 times. Close the bracket. Okay, now we are now we are supposed to give the how many number of potassium are there. Okay, that should be given. How to give that? Only if we know the charge on this anionic complex, it is possible to give the number of potassium. Okay, how to fix this charge? Because we know the oxidation number of chromium, from this it's possible to fix the charge on this entity. Okay, so that we can do, right? So chromium, listen carefully, Cr C2O4. Okay, 3 times. Understood? So now we know this is 3. Okay, so it is +3. +3. What is the charge of this oxalate? How many ligands are there? 3. Is it not? 3. What is the charge of this oxalate? It is -2. Okay, so +3. This is +3 -6. Okay, that's equal to -3. Fine. So the charge of this anionic complex is -3. Understood? It is -3. Since if it is -3, if the charge on this anionic complex is -3, if it is -3, this would be +3. Okay, that means here we will be writing as 3. Okay, so this is how we should write. Understood, students? This is how we should write. Okay, so let us see the next one. Tris ethylene diamine chromium 3 chloride. Tris ethylene diamine chromium 3 chloride. See here, the name of the ligand is given first. Okay, so the name of the ligand is given first and the name of the central metal atom is written as such. That means it is a cationic complex. So in the beginning we will be having the cationic complex. Understood? So we will be having the complex. So Cr. Triethylene diamine means here we can write as ethylene diamine is written as En. Tris. So that means here we will be having 3. Okay. Now close the bracket. Okay. And then finally we are having chloride. So that means here we will be writing chloride. But now we are supposed to fix how many chloride atoms are there. Only by fixing the charge, net charge on this coordination entity or the complex ion, it is possible to fix the number of chloride ions. How to fix this? By using the oxidation number of this chromium. Understood? So let us find out. How to find out? Chromium En 3 times. Okay. So chromium it is +3. Understood? Chromium is plus 3. What is ethylene diamine? It is 0. Okay, plus 3 into 0. Okay, it's a neutral. Okay, neutral ligand. That means it is plus 3. Okay, so the charge on this entity will be plus 3. 3 plus. If it is 3 plus, here it will be 3 chloride. Okay, so what could be, how will you write here? It is Cl3. Understood? Since it is, if this can Cl3, if it is Cl3, it can be written as 3Cl minus. Understood, students? This is the format, 3Cl minus. Okay, that means 3 chloride are there. Okay, so this is the formula. Understood, students? Say, let us see the next one. Sodium hexafluoridoaluminate. Sodium hexafluoridoaluminate means sodium is written in the beginning. The metal name of the cation is written in the beginning. That means it is a simple ion. Okay, so Na. Now we can start the complex. So aluminate, hexafluorido. So hexafluorido is the ligand. Okay, so fluoride is the ligand and it is 6 times. Next comes aluminate. Okay, so aluminate is the metal, central metal atom. So you write aluminate. Then hexafluorido. Hexafluorido means fluoride 6 times. Understood? So this is the compound. Now we are supposed to fix the number of sodium atoms. Okay, so how many sodium atoms are there? Okay, for that we can make use of this oxidation number. So how to find it out? AlF6. Okay, so what's the oxidation number of aluminum? It's plus 3. Then plus 6 into for a fluoride it is minus 1. Is it not? So plus 3 minus 6, that means it's equal to minus 3. Okay, so the charge on this ion, this complex ion will be minus 3. If it is minus 3, then sodium will be 3 here. Okay, that means 3Na plus. Understood? Okay, so we'll be writing as Na3. Okay, so this is the name of the compound. Okay, this is the structure of the compound. Next comes sodium hexanitrocobaltate. Okay, so how will you write this? Sodium means Na directly. Then you start the complex. Cobaltate. Hexanitro is the ligand. Cobaltate is the, cobaltate means it's an anionic complex. So cobalt. Okay, then hexanitro. What is nitro? NO2. Hexa. Okay, so we have written. Now we are supposed to fix the number of sodium atoms. How to fix it? Yeah, right, come on, right? CO NO2 6 times. Okay, so 3 plus 3. Okay, then it is minus 1. Okay, so minus 6. What's the answer? It is minus 3. Okay, so since it is minus 3 there, since it is minus 3 at the top entity, here we will be writing as 3 plus. Okay, Ca3Na plus. Understood, students? This is how we will be writing. And the last one is hexa aqua manganese ion. It is an ion. Hexa aqua means H2O 6 times. Manganese ion. Okay, so that's no metal, only a complex is given. So manganese Mn, then H2O 6 times hexa aqua. Okay, now we are supposed to fix the charge on this entity. So Mn H2O 6 times, is it not? So what's this? Manganese, it is 2 plus 2. Here it is, the water is a neutral ligand. So obviously it's 0. Okay. So if so, manganese oxidation state is, so here the charge on this entity will be 2. Okay. So it will be 2 plus. Understood? So it is 2 plus. Understood, students? So this is how we should arrive at the structure of the coordination compounds from the Iupac nomenclature. Well, fine, students, you might have understood the method of writing the Iupac nomenclature of coordination compounds and ions. I shall meet you with another important topic in a short while. Until then, it's Anita Raj signing off from you. Thanks for watching.